Welcome everyone to today's information session for Lunarlab 2026. So really great to have you all join us this afternoon. Cannot believe it. We're already at the end of February, and the excitement of Lunarlab 2026 is building. So today's goal is really to give you a flavor of what to expect from the program this year, get you excited, and hopefully, if you haven't considered applying yet, also push you over the edge and get you applying. So very briefly, a bit of run of show. So we'll start with some welcomes and introductions, and then we'll jump into some of the nitty-gritty, the programmatic elements. What is FDL? What is Lunarlab? And diving into the operations of the timelines, the sprint itself, and being part of this incredible community. We'll also have some reflections later from alumni, and also great to see Rahul joining us on the call here. So faculty from 2025 and all round FDL superstar. The other faculty member as well is Sylvester, who will share some thoughts, and then we'll jump into the application itself, some information around that, and most importantly, want to be spending time on Q&A. So this session is very much about you. It's supposed to be interactive, and we want to dive in as deeply as possible to answer those questions. So for those of you not familiar with Google Meet, we're going to be using the Q&A function. So at the bottom right of your screen, you should see 9 little dots. If you click on that, you will be able to see the Q&A functionality. So you can start with a question. I'll just do one as an example. Very simple question. You can see that pop up. One of the nice things with Google Meet, the functionality, is you can upvote a question. So if you see someone else ask something that you really want answered, please do upvote, and keep those questions flowing throughout the session today. When we get to the end, it's going to be all about Q&A, and we'll get through to those upvoted questions first. We will cover all of them, so don't you worry about that. But as thoughts come to mind, please do pop them in the Q&A. Without further ado, last thing to actually mention, we will be recording this session for the folks who cannot make it, and sharing that after the fact. So just please bear that in mind. Let's get cracking. So some introductions. I'm Mike Haynes. I'm the FDL program lead for Lunarlab, and then also the lead on some of the sister programs, and we'll chat a bit more about that. And then a little later, we'll have Sylvester joining as well for some Q&A. But incredible to see Rahul also here. So we are lucky enough to have faculty from both faculty from 2025 joining us on the call, and we'll jump into that a bit later. So to get into the FDL 101 and contextualize what is it that we would do, have a simple question around this, and that is, can you do world-class AI research over the summer? And the resounding answer to that is absolutely yes. For the last 11 years, FDL has been doing exactly this, bringing together the best and brightest minds around the world to be tackling the big questions. And the real question I would actually be posing to you is, what research do you want to lead the world in? FDL is the opportunity to do exactly that, and to do something that you never thought possible before. In a more general context, today's session is for the Lunarlab program. There are 5 different programs that we have at the moment that are being focused on. The other sister programs in particular are Heliolab, which is a main program funded by NASA, focusing on heliophysics and space science and everything related to the sun and its impacts on humanity. Then there's from ESA Earth Systems Lab, so that is looking at the Earth system in a general sense, everything from climate change to crisis response. And then spun up last year was Lunarlab. So this is in partnership in particular with Luxembourg Space Agency, and looking at lunar science and lunar resources, and really unlocking the potential of AI in these domains. For 26, there's also the potential programs of FDL Med and Flight Lab that are waiting in the wings to be announced exactly the format they would take. And depending on the situation, these might be challenges for 2027 as well. So please do watch this space. Not added here, but very exciting, is that we are spinning up a kind of adjacent program called FDL Foundations and FDL Foundations Africa. This is a FDL program specifically looking at the use of foundation models for application, and we're going to be kicking that off in Africa this year. So very exciting. And just to say that this community, this info session for Lunarlab is not just siloed in this sense. It is the entire FDL community that you become part of as part of Lunarlab. But what is it that FDL actually does? Well, we specialize in fusing subject domain experts with data scientists around the world to really tackle the big, open, tricky problems, and do that in a very intentional way in a sprint format, taking the academic rigor and industry best practice, merging those together, and through quite a defined and supported process, getting to a minimal viable product, whether it be a pipeline or a paper, in an incredibly short amount of time. So very different to how science is done normally, and very inspiring to me in that sense. Now, to do that, we can't do it alone for sure. And I must say that I would like to take a moment to acknowledge the partners involved here. So I've already mentioned that in the 3 flagship programs, Earth Systems Lab, Lunarlab, and Heliolab, the main partners are ESA, Luxembourg Space Agency, and NASA, respectively. And for Lunarlab in particular, it's not just Luxembourg Space Agency, it's also ESRIC, who really help guide where the program goes, and that's, but we also cannot do what we do without the compute and industry partners. So huge amounts of support is given from Google Cloud, NVIDIA, our friends at SCAN, and in the context of Lunarlab last year, also expert mentorship from the DataRock team, an Australian prospecting firm, and of course Lux Provide, which is also in support of the compute needed to do the amazing research over summer. Just to say that this is also acknowledged across our industry partners. It goes 2 ways. There's a huge amount of support that they give, but we also help them really stress test their latest hardware, and it's a incredibly symbiotic relationship. So have quite a deep relationship, obviously, with Google Cloud and NVIDIA, and very exciting to be part of that. So for the last 11 years, we have really been pushing what AI can do. And as we all know, AI is very different now compared to what it was 11 years ago. New and shiny thing then, but now really in our day-to-day, absolutely critical to how a lot of us approach our work. So what do we do across the labs? We really focus on applications, discovering, for instance, how the sun affects us, the sort of dynamic system we find ourselves in on Earth, and then obviously the exploration aspects, particularly us returning to the moon and deep into the solar system. So with that applied side of things, we definitely do focus on having tangible applied outputs, looking not just at the theoretical side of things, but very much protecting our planet's infrastructure, our communities, bringing that all the way back. And that has been noted in various different awards and outputs. So over the last 11 years, there have been well over 50 pipelines, numerous awards for a lot of the research that has been done over the 8-week sprint. So to emphasize here, it's not just about very quick prototyping, it's very much about impact and taking that research forward in a world-class setting. But with the comment about it being applied, it isn't just application for application's sake. We do ensure that there's a deep science focus in all that we do. That's the beauty of FDL. It's a interdisciplinary team that tackle the problems. So you have incredibly knowledgeable domain experts who come and bring all of that science rigor, and then the folks who do come from a much more ML, say, background, who are able to unlock the new potentials or the new potential that we have from AI and the approaches. The way we think about things as well is not as a sort of a single, here's a single data set, pipeline, and a one paper and solid, and that's the end of it. We really are thinking about AI for science as AI infrastructure for science, applied orchestration across the board, that you have outputs that are no longer siloed but are able to be queried. I mean, that's what we're all experiencing right now, the revolution with agentic systems, and pretty much bringing that into a science aspect. So thinking, for instance, about continual learning, how do you create a model that is relevant in the future, and how do you unlock the potential of a whole bunch of different foundation models all contributing in a way that you were never able to do before. So we have a real, I guess, legacy of doing this work, and that is very much where we want to continue moving forward towards a fully orchestrated approach for AI in science. And that can be seen very much in our different program outputs from the various different years. You can, across our sort of Earth and near-Earth space and into the heliosphere, see these capabilities that have been deployed and lead to impactful outputs. I will go through 3 sort of case studies just to bring this to life a little bit. So some previous work from FDL looked at flood segmentation from on board. So the idea here is really, as rapidly as possible, being able to identify the extent of flooding and to provide that sort of very rapid response capability and get people in the right places as quickly as possible. So this is the ML for Floods workflow that has seen application in various different contexts in an operational sense. Another one over here is StarCop. So this is a project that has been matured, and there was a sort of follow-up from last year, which looked at, in particular, identifying greenhouse gas emissions, methane in particular, using multispectral and then hyperspectral data. So you have this idea of a tip and a Q satellite, one that can identify the initial emission, and the other Q satellites who then focus in on that and get concentration levels and such. This solution, again, had an onboard component, and the pipeline itself is being used right now as part of the UN methane and alert and response system. So again, taking something from an initial concept all the way through to application and doing this within the FDL sprint. The third case study, just to show something from the heliophysics side of things, is the common thermospheric drag model. So this is a model that's also been matured over a few years and sees operational deployment at some partner institutes. In this particular case, SWTREC. And thermosphere is really the part of the upper atmosphere in which our satellites operate, and that drag density, as it changes with space weather conditions, affects the longevity of satellites. So it's incredibly relevant to constellation management and general satellite operations. With all of this, we come to 2026, and across all the programs, we're asking the same sort of question, the same thematic, and it's centered around building a mission control for the future. And the question here is, what is the capability you need, whether it be on Earth, on the moon, or the sun? So for Lunarlab, it's really around a cognitive layer for the moon as a capability we are striving to. Now, this is a general question, and there are a few initial thoughts around that. What we are seeing and what we are striving towards with FDL is this kind of idea of a frontier intelligence stack. So again, going back to that idea of not just AI for science, but AI infrastructure and orchestration for science. How do you develop a capability stack that starts, say, with perceiving, where you're getting sensors and new data, processing that, and getting all the way to planning, which may include reasoning and agentic workflows. So thinking about this, how do we really build onto the stack? And as a sort of initial primer for the kind of challenges that would be interesting for 2026, a lot of this is built on the incredible work of the team in Lunarlab 2025. So there was a single research challenge, a very bold question about, can we build the first multimodal foundation model for lunar resources? And the team went about and did exactly that. So there's a explosion of capabilities that come from this work, and a natural continuation is the maturation of the lunar foundation model. And how does this actually relate to different downstream use cases? Another aspect of this is a more general question around model distillation and edge compute. Can we take foundation models such as Lunar FM and deploy them on edge devices? So if you are thinking of operations on the moon, how do we actually make use of the insights that we can get from foundation models in practice? And how do we supplement those pipelines? Another avenue to explore is around the operational context for resources. So again, from building on from last year, there was an initial prototype on the agentic layer and a reasoning framework within Lunar FM. That reasoning framework is something to really build up on, and then allow one to access the wealth of information in literature, in the different modalities that are encoded already, and translate this into downstream use cases. So kind of big open questions around this, and merging not just the sort of AI side of things, but also simulations and supplementing where there are gaps. So with that, I hope that gives a kind of a good picture of a lot of the research around FDL and Lunarlab. But I want to spend a few minutes now just going into some of the nitty-gritty about how FDL works. So I've alluded to the fact that it is really driven. The engine behind FDL is interdisciplinarity and iteration. It's about bringing together the right people to tackle these very difficult problems and providing the framework for them to do that. So typically within FDL, there are 2 faculty members, 2 leads, with 4 researchers who then are part of the research team and would take that challenge and go as far as they can with it. But that doesn't sit in isolation. The program itself, all the research teams are part of the same program together, and that has the support from the FDL team. So on the call today is myself, but you also see Carmen and Tom, who are part of the support team, and they really make the magic happen as well. So we put the kind of the framework together, create the container where it's a very stable process-driven container, and then put in the compute from partners, the experts, the amazing researchers and faculty, and let the magic happen as we go along. The other aspect is we've been speaking about the sort of summer/8-week sprint, but of course FDL is not just a 8-week sprint. It's an entire year endeavor. It's started already with challenge definitions, exploring the opportunity space. There's then the recruitment phase, which is part of this call as well. And then once that matures, getting the data and the compute all ready to go for the sprint. So everything is teed up for you to do the best work of your life. Then after the sprint, there's the opportunity to refine and obviously disseminate the outputs through publication and conferences as such. Where we are right now, it's in that initial stage. So just wanted to bring to life a little bit how these challenges come about. So there's a significant amount of work mapping the opportunity and solution space, which translates into one-page challenge ideas and pitches, and then into a thematic workshop. We often call that a big think, where we really pull out some of the very key and compelling ideas and mature those into concept memos, which is where we are right at the moment, ultimately coming to the defined research challenges, which then are ready for the faculty team to take forward and then the researchers to join. In terms of timeline, what that looks like, so we have the information session today, which is not the 25th of February, but it's the 26th. And then over the next few weeks, we'll be confirming with faculty to take things forward. Applications, importantly, for those of you on the call today, close the 31st of March. So that's a date for the diary. Then we progress with the application process and the various different rounds, with coming towards sort of mid-May, the teams announced. We have a kickoff on the 15th of June. So that's the start of the sprint that goes on through to the 7th of August. At the end of the sprint, there's a sort of TED Talk style live showcase that really celebrates the progress and achievements of the sprint. But there's a significant period of refinements which leads up to a technical showcase towards the end of September/October, which really dives into the amazing outputs that were achieved during the sprint, but at a much deeper level, and where our partners really come and see what was done. Then towards the end of October, results get released, and there are, of course, the end-of-year conferences in Europe, AGU, or a bunch of others that folks present at. Within the sprint itself, just to bring that to life, so there's an 8-week process. There's the boot camp, which is the first week and really gets the ball rolling for the various different teams. This, at the moment, is a in-person component. The exact details will be confirmed and communicated as soon as they are nailed down, but that is the current stage. And then we progress into the sprints. So one of the things I want to highlight here is the iterative components and the formal reviews that make FDL as successful as what it is. So these FDL formal Fridays, or the F3 reviews, are distinct signposted milestones that you work towards. And the incredible thing here is having this process associated. One gets to the end of the 8 weeks and one has a portfolio of work that speaks for itself and really does wonders in presenting the work and driving that progress. So this is all parts of the process that we run and the support that we give. The other thing to just note is, obviously, before the sprint itself, there's the countdown phase with onboarding for various researchers and faculty teams, and get you all familiar with the various tooling that we use for in particular, the virtual parts of the sprint from week 1 onwards, and the compute environments. So you will be as prepared as possible for the sprint. And then, as noted, in the second half of the year, there's the opportunity to mature those results, get them ready for publication and presentations at various conferences. So fantastic track record at these flagship conferences. And we're very aware that in academia, publication is hard currency, so would support that every step of the way. But yeah, spoken a lot about process and about the research, but the one thing to really emphasize here is the FDL community. Community is at the core of what we do. It is what makes FDL special. It's really what drives us to do this year in, year out. And it's probably, to me, I started out as a researcher and joined as faculty. Then subsequently, it's the one thing that really struck me, and I cherish my experience purely because of the people involved and the amazing work that we've done together. And just to stay on this, asked a few folks from 2025 to share their thoughts, and the resounding sort of theme amongst all these different comments is about the people, the way we do science so differently. It is an intense environment. It is a 8-week sprint, and that is exactly what it is. But it's doing it with some of the most amazing people that you would ever work with. So, yeah, just want to emphasize that aspect of FDL, and of course that also comes back into the application process as well. I will just say, within the programmatic side of the sprint, it isn't just about the research. There's some very intentional sessions around what we call the 7 C's. So we have an amazing collaboration coach, Belina Raffi, who joins us every year and helps us as a team really find our groove and get moving as quickly as possible, and keep operating at this high level. With that, there's also a design team that you see the amazing graphics throughout this presentation. They are very much involved throughout the sprint and really helping you tell the story of your research as well as possible. So I want to look back very briefly at the 2025 challenges to give a bit of a flavor, and in particular with Lunarlab, a lot of the kind of potential in 2026 is built on the work of 2025. I must admit that with Raul and Sylvester on the call, they might be cringing and saying I get this all wrong, but I'm going to attempt to color in some of the work that the team had did last year, and would love you to interrupt if I am straying. But last year, the Lunarlab team released literally the first foundation model for lunar resources, a multimodal model that takes into account a whole bunch of different global mosaic data sets, and produced embeddings that then could be used for downstream use cases. So I'm going to run through very quickly what was done. So the real underlying question was whether you can extract new insights from all these different measurements, creating a set of embeddings. This is a representation of one of those. And to do this, you had to go and create a lunar foundation model. In this particular case, it was a multi-MAE masked autoencoder model. What does that really do? Well, it's based on the typical masked autoencoder model, masking your inputs and pushing out to a ground truth, and creating these sets of embeddings that encode this multimodal information. One of the first things you can actually do with this, and this for me was amazing to see happening in real time with the team, is doing the reconstruction. So from your masked inputs, being able to reconstruct the various different modalities and compare it to the ground truth. And just something for someone like me who's not an expert in the field and very much a practitioner. I just thought it was fantastic to see Grail, the gravity field measurements, with a single point in the masked inputs, being able to produce a rather convincing reconstruction of the ground truth because of this multimodal embedding capability. Some of the other outputs from this, the second you are able to have embeddings, you can do all sorts of very interesting stuff, one of which is a similarity search. So if you have embedding, you can measure the distance as such and find the nearest other embedding, which gives you an idea of similar areas. So if you are looking at a landing site that you know is viable, you can find additional ones. That said, we do need to be able to trust our embeddings. So one of the other outputs is an importance map. So one can really interrogate where is it that the actual model is learning and identifying those areas of interest. So here you can see an importance mapping with optical and picking out those craters very clearly. And so a foundation model is a great first step, but one of the real benefits of it is once you start interrogating downstream use cases. So for Lunar FM, this was very much associated with lunar resources and looking at mineral concentrations. So again, being able to reproduce or predict those various different those mineral concentrations and density maps. Another one of these outputs that I was very excited about and seeing it happen in real time is the very small sampling that the experts can contribute to this Lunar FM and be able to get a huge impact in the performance of that prospecting tool. So this for titanium dioxide, but with as simple as 5 different positive or negative examples, hugely increasing the efficiency of the prediction or the accuracy. And this just shows how with a lunar foundation model and an expert together, one can really do some incredible work. And there was obviously one more thing, and this is what I had mentioned initially. There was a prototype agentic layer that worked on top of Lunar FM. So those embeddings, they could be cast in a way such that you could actually interrogate them and have a lunar agent basically be able to interrogate the embeddings and the literature associated. So huge amounts of potential in that, and really excited to see what comes next. But yeah, I've done a lot of talking. I think it's time to get some other folks involved as well. So I don't know if Sylvester is online.
Yes, I'm here. Yeah.
Yeah, there he is. And I wonder, Raul, if you also wouldn't mind, Craig, I should see, to jump in on some of these questions. I think it's great to have you both join us this afternoon, and both coming from extensive experience of FDL, not just in Lunarlab, but more generally. So I've got a couple of quick priming questions. I think for both of you, having experienced FDL over quite a few different challenges and different years, what is it that brought you to FDL in the first place? And maybe I'll just start with you, Sylvester, on that.
So quite a few things, I would say. What drew me to FDL and Lunarlab as well was that this was a real scientific problem. And that's something I love, something I like very much. So what I'm trying to say is, in other words, it wasn't just, an exercise in search of application, okay? So that's one. Lunar data is incredibly, rich, complex, and it's fragmented, right? Fragmented across, instruments and modalities. So the challenge of building a shared representation of the moon was, I would say, immediately compelling. And also what I found especially valuable in FDL was the combination of pace and I would say how complex things are, okay? So you have strong people from different domains working very closely, and I think that's amazing. But also that creates very unusual research environment. research environment where you can move quickly but still stay grounded in the science. So I think that's fantastic about FDL. And also one more thing, what was exciting for me is that the work became very tangible, if you will. So what I'm trying to say is we were able to build multimodal lunar foundation model, right? That supported things like similarity search, geologic classification, TiO2 prediction, all those things, right? And even a prototype, natural language interface to lunar data, which is just fantastic. So I would say for anyone thinking of applying, this is definitely the place where you can work on ambitious ideas and still, and the sprint with something real, something substantial. Yeah.
Thank you. Not to put you on the spot there, Raul, but if you have any thoughts as well from your side.
No, just likewise, Sylvester. I mean, always in the same lines. I mean, what brought me in originally, I think it's been already 6 years working in FDL challenges. And what brought me in was looking to do something, yet another thing exciting. Different people, different community, and what kept me coming back, it is that it was the mixture of challenges, because sometimes challenges are hard, and in the very moment where you're trying to solve them, it's not easy. It's not easy. You have to have stamina. You have to have vision. You have to have good communication with your team and so on. So all these things played out across all the situations that we solved. Not all the situations are trivial. So looking back, all the things that we sorted out in many circumstances, it made me grow a lot, and it keeps me growing a lot, and that's what excites me.
Amazing. And yeah, as a sort of a direct follow-up to that, with obviously it's been 6 years in that, and if you kind of cast yourself back all the way to the start, what is the one thing that you would love to have told that version of you as a sort of a heads up, or that you wish you had known coming into FDL, and maybe being able to share that with folks on the call today? And again, I'll just start with you, Sylvester.
That's a good question, actually. I think I would have told myself a couple of things, like pace is real, okay, and I like that. I love the challenge. That's something I enjoy very much. But you should actually so you should arrive ready to make decisions quickly and not wait for perfect certainty and those kind of things, right? One more thing, the multidisciplinary part is, I would say it's not a label, if you know what I mean. So what I'm trying to say is a lot of the value comes from learning how planetary scientists, ML researchers and engineers think differently. Okay, they approach things in a different way, and how to translate, I would say, between those words. Okay, so I would say that you shouldn't go in expecting a neat linear process. That's just it's not a good idea. So the sprint works best when you stay flexible, test aggressively, okay, and let the problem kind of sharpen as the work progresses. So yeah.
Amazing. Thank you. And maybe Rahul, if there's a thought there as well on.
To me, it's a really nice question. I mean, to me, one of the things that is more fulfilling, that just builds along the years, is seeing the proof every year that everybody is capable of doing many more things that we all think we are capable of.
Mm.
We see that every year.
Yeah. Amazing. Thank you both. I'm going to move us forward, but not to cut this off, this discussion, but very much to get to the Q&A. So everyone on the call, please do also include Q&A to our amazing alumni here, and then we can get to that. So a lot of information being thrown out today. The recording will be made available, but I'd also encourage folks to have a look at the Lunarlab specific website, lunarlab.ai. You can also navigate to the assistant program website through FDL AI, and yeah, you will be able to find the various different Lunarlab research outputs over the years, the technical results and findings document, which really deep dives this. So effort from last year in particular, with the live showcase recordings and a whole bunch of other bits as well. And then to the key details. So I am going to quickly give a little bit of an overview, but then going to ask Carmen to explain a little bit about the next sort of steps for all of you folks. So applications are very much open. Please do go to lunarlab.ai/apply to do such. The applications themselves close on the 31st of March. And even though that is the deadline, please do apply as early as possible. The sooner we get your application, the sooner we can move forward with the next steps. And of course, the applications to the sister programs are also open, and you can read more about all of these at FDL.ai/apply. The QR code on this particular screen as well should do the trick for you. I do want to emphasize that Lunarlab is a program for postgraduates, so it isn't aimed at a sort of undergraduate research level. It says over here PhD and postdoc level researchers. That said, very aware that in certain fields, computer science, that's being a good example, the master's level folks are incredibly experienced and often have much more experience than I would ever have coming from industry backgrounds and such. So that's just to say that it's not an undergrad level application. We are looking for quite senior folks and senior experience. The actual sprint is also supported in terms of a stipend, so for researchers and faculty. And then, as we've mentioned already, it's an 8-week-long sprint, mid-June to mid-August, which is very much a full-time endeavor. As I noted as well, we're very aware that publications and outputs are part and parcel of academic currency, and really we do encourage folks to be pushing towards this. It is all about open science as well, and from our partners' perspective. So that is very much encouraged. And you will of course meet with a bunch of incredible people, both within the FDL community, but also the Lunarlab partners. So from Luxembourg Space Agency, ESRIC, Google, NVIDIA, University of Luxembourg, and many others. But yeah, I just wanted to give Carmen a opportunity to walk through some of the next steps.
Thank you, Mike. So we have the initial application, which is the online one through the website, and then that will take you through. Once we've sort of reviewed applications, it will be a culture interview, where it will be more relaxed conversation, just getting a feel for how you work within a team. And then from this, it will go to a technical interview, which will be one of our faculty and, someone who's an expert in the field. And yeah, hopefully that's helpful. Have I missed anything, Mike?
No, I think that's absolutely it. And yeah, I think it's really also just to flag here that there is a talent pool that is considered, and we really do match your profile with the various research challenges. So it's not a reflection at all on your potential. If there's just not a fit within the the research challenges, then that is the kind of main criteria for progress from the sort of final round into actually being a participant within the 2026 cycle. And that final selection also happens from a faculty team perspective. So the balance of having the right sort of domain experts and the machine learning folks in the same team. And yeah, if anything has changed, please do let us know. Have a few facts here just to go through very briefly, but then we'll jump into the Q&A. So one of the questions we get a lot is, well, can I apply as a sort of a domain expert, or like, what am I actually? And I'll just really encourage you to choose the thing that you resonate the most with. This helps us sort of get that team balance just right. There are a few different options. So there's the kind of the domain experts, loosely termed energy/space, and then there's the more AI ML side of things. Obviously there are the hybrid shaped individuals with a bit of both, and even so, if you are a hybrid individual, there might be a bit of an emphasis on either, so please do add those in. And then of course there's the software engineering aspect. So within this vision of creating AI infrastructure for science and not just a single pipeline, there's a lot of plumbing that needs to happen, and that comes from the software engineering aspect. And then, yeah, the other question is very much around where the sprint actually takes place. So at the moment, bootcamp, that first week is an in-person component. If that changes, we'll communicate that at the earliest possible opportunity. But then the rest of the sprint is virtual. So that's very much the case. And then another thing is, when one's reviewing this, one often thinks, oh, I'm not sure I meet all the criteria that still apply. And please do. We really are looking for contributions from all sorts of people. The more diverse the pool, the better, because, yeah, within those teams we put together for research challenges, we do want to see all the different skills coming together in this interdisciplinary way. That said, it is an incredibly competitive program, and there will be some prioritization with those research challenges in particular, and then in terms of some of the applicants who are best suited. Then finally is Lunarlab, a full-time commitment. Yes, it is absolutely a full-time commitment, and one has that 8-week period, often stretching one to some degree. The last bit on this particular slide, we'll share everything, is how else to get involved. So there's the research and the faculty roles, which we have discussed a bit, but I also want to flag that there are, of course, very different roles to get involved with and to contribute, and that includes milestone reviews. So with those formal reviews that we do, we really do need as much input as possible from the community, and this is a great way to get involved without being hands-on all the time. And there are other additional roles, so please do reach out, articulate your interest in those roles, and more than happy to have a discussion around that. But really want to be getting into the Q&A. So just as a reminder, in the bottom right, the 9 little dots in a square, if you click on that, you can get to Q&A, and we'll run through some of those. And if you would like to come off mute, more than welcome to do so as well. Just put a hand up. On this particular slide, once again, we have the QR code for the application page. So, okay, jumping into the Q&A. So we've got Roshini asking about using computer vision techniques or image analysis and reconstruction, or just ML models and agentic AI. And yeah, I mean, I think this is a great question. At no point do we sort of prescribe this is the only way to do something. It's very much about the team deciding the best direction to take this challenge and make it their own. So yeah, if you are coming with computer vision techniques you want to go for, absolutely. Okay, Vic, what other lunar missions like Lunar Prospector have you incorporated so far and to incorporate? Again, I would say that there is a quite an extensive portfolio, not just from the Lunar FM work that has looked at a whole bunch of different data sources. I think with the work from last year, I can't recall that Lunar Prospector was used. Raul, Sylvester can correct me if I'm wrong.
We use the Lunar Reconnaissance Orbiter data mostly.
Yeah.
Which has several instruments on board. Mostly that because it provides global coverage.
Yeah.
It's quite a few years.
Yeah. And there again, it's a really an open question to the research team about what data is available. If you feel that there's a particular additional mission that would really complement this particular research question, then that's very much open there. Raul, sorry, yeah.
Yeah, just to complement on that and also on the first question, just to resonate with what you just said, Mike, it is not that, I mean, it is up to the team to come up with how to solve, well, how to finally define a problem, because the problems that we are given, they are not fully defined. It's part of the game to come up with and make choices, what part of the problem we're going to solve, and then how we are going to solve it. It is not that FDL tells you, hey, you have to use a vision transformer to solve this. It is up to the team to decide that. Now with that, I mean, out of curiosity, if you guys want, we have used a lot of vision transformers in the past for Earth observation and also for the lunar project last year. But we are starting to use also multimodal LLMs as well, because their image capabilities, RGB imagery capabilities are quite good. So we are starting to use them as well. But again, I want to resonate very much with that. It is part of the challenge, deciding what you want to solve finally and how do you want to solve it.
Yeah, absolutely. Thank you for that, Raul. Yeah. Okay, so and just going down, location for the boot camp and the mode, remote or on-site. So the final details will be communicated as we progress, but maybe to use last year as a sort of a baseline, this was a boot camp held at Isrin in Frascati, Italy, ESA site, in conjunction with the Earth Systems Labs as the program together. And then there was an additional half a week spent in Luxembourg with the partners at Luxembourg Space Agency and ESRIC in particular. So we would love to bring that forward again in 2026, and we'll communicate exactly what that would look like. In terms of remote versus on-site, for the boot camp, it is incredibly strongly encouraged that it is a in-person component of the program. So on-site, if there is a particular exception that needs to be made, we can discuss it. But this is the opportunity for the team really to meet each other, to get to that problem definition that you want to solve as a team, to Raul's point, and incredibly important to have everyone joining that. So yeah, that is it. And okay, got another question up here. Is there a week in between the if there's a week in between the 8 weeks that I might be unavailable, would I still be able to participate? Short answer to that is that it is a full-time program, and with the team really moving incredibly fast towards that end goal, if one isn't able to commit, then a lot of that workload does shift to the the other team members, which is very difficult. So I think in this case, let's discuss the particular sort of scenario in which you're dealing with, and in the application process, there's the opportunity within the cultural interview and the technical interview to flag some of these aspects, and that can be considered throughout. But we would really encourage folks to be fully committed and push through for the full 8 weeks. Yeah. I think that is all the Q&As that have come through the Google Meet. But if there are any other thoughts percolating, please feel free to pop a hand up and ask in person. I'd also say that a lot of these questions you will find answers to online on the FAQ, and if you have any other concerns, please do reach out. More than happy to discuss your particular circumstances, and really hope that as many of you as possible have left today's session feeling excited and inspired. We're just about at the hour mark, which will bring us to a close. But yeah, this definitely doesn't have to be the end of the conversation. Reach out at any point, and we can support you in your application process. I think with that, I'll give it a moment or so before wrapping up, and thank you very much to our faculty, Raul, Sylvester, for joining us this afternoon. Really appreciate you always, and have a amazing Thursday. Take care, folks.